Today we're going to talk about the communal level health effects of forest fires. There's a lot of research out there on the health effects of particulates, chelkakim, specifically related to air pollution. There's some research on the health effects of fires, not specifically forest fires, and there's less research on the health effects of forest fires. But I think there's plenty out there that we can learn from. This is a quick overview. We'll discuss the toxicology of forest fires, the epidemiology, and then talk briefly about what the potential health effects of the Carmel forest fire are for the residents in Haifa and in the area. So this is a comparison that's been made more than once, the connection between the Carmel forest fire and the World Trade Center. When I was in medical school, I worked briefly at the World Trade Center clinic in Manhattan, where we followed about 2,000 firefighters that were in the World Trade Center to find out what the health effects are. And clearly there's a difference in proportion between these two disasters, but they are both national disasters that we can learn a lot from and have specific health effects. The real question is, how do we compare the two? Which one is more unhealthy? The urban fire from a burning building, which is filled with everything from toilet seats to copiers to plastics to asbestos, or the burning of a natural ecosystem such as a forest fire. Many people would assume that a building on fire, something that we see in the urban environment, is more toxic, but from the literature we're going to present, we'll see that that's not always the case. There's three things we need to consider when we talk about toxicity. What are the chemical properties of the thing being burnt? What's the magnitude of exposure? How much is actually being put out into the environment for people to inhale? And what's the population at risk? First, let's talk about chemical properties of forest fires. It's not correct to think that just because a forest is burning that it's healthier than a building because a forest is natural. The problem with a forest fire is you get incomplete combustion. And whenever you have incomplete combustion, you're left with inorganic gases such as carbon monoxide, ozone, nitrogen oxides, which are asphyxiants and irritants. You have hydrocarbons such as the saturated hydrocarbons like butadiene, the aromatic hydrocarbons such as benzene and benzoyl-pyrene, which are mutagens and carcinogens. You have oxygenated free radicals such as formaldehyde, acetic acid, and the quinones. All of these are carcinogenic. Teratogens, which means that they have developmental toxicities. They're also irritants and allergens. You have the chlorinated organics, such as dioxins. You have this not only in the burning of plastics, but also in the burning of a forest fire. And these are endocrine disruptors, which means that they affect the endocrine system, can cause things like diabetes and hormone changes. And they're also neurotoxins. They can cause things like Parkinson's and Alzheimer's. Particulate matter, such as large particulates, PM10, and smaller PM2.5 that we see in ambient air pollution, is also found after a forest fire. There's one very eloquent study that was done out of California last year where they took the soot, the exposures from forest fires, and then an equivalent amount of particulates from air pollution, and they injected them into a rat's lungs, multiple rat's lungs. Even though it doesn't sound like a nice thing to do to the rat, it's a good way to see what happens. After 24 hours, we see on the top level, this is the wildfire sample, and the bottom level, this is from air pollution. The key thing to keep in mind is that the amount of pollution is the same. So they took air pollution and condensed it so that the quantity of air pollution is the same as the quantity taken from a forest fire. And on the top level, we see that you have increased levels of inflammatory cells, leukocytes, pneumocytes, which is a sign of inflammation. You have destruction of the alveolar spaces, and you have destruction of the overall morphology and architecture of the lungs, which you don't see as much of a finding in the ambient air samples. Compared from forest fires to pollution that you see in a city, you have increased protein and cellular fluids in the lavage of the alveolar spaces. You have increased swelling and edema, and you have increased lung damage. So, b'kitzur, fire pollution from a forest fire is 10 times more toxic than an equivalent amount from ambient air pollution. Something to keep in mind. We talk about having polluted air in Haifa, but even a forest fire such as the one we have here is 10 times the amount of toxicity. So we've talked about chemical properties. What's the magnitude of exposure? I think just if you look at the pictures, you can realize there's a difference in magnitude. A forest fire burns thousands upon millions of tons of materials, while an urban fire, such as a building fire, is a fraction of the amount. So when you talk about the magnitude of exposure and the levels of pollution, there's a clear difference between a forest fire and other types of fire. Because of the large burning, we have extreme peaks in exposure. The World Health Organization standards for particulates is about 50 micrograms per cubic meter. For fine particulates, it's even less. An article of California forest fires a few years ago found average levels of 190 micrograms per cubic meter. So you have about 4 times the amount of air pollution during a forest fire incident in the city versus regular ambient exposures. The last question is, what's the population at risk? Usually, an urban fire has more people at risk. Why? Because it's in a city and that's where people live. The Carmel forest fire was a unique event. When there's forest fires in California or India or in the forests in the Pacific West, these are areas that are removed from the population. Here we can see that the fires were right next to the city of Haifa, the 3rd largest city in all of Israel. The combined population of the area affected was about 600,000 people. So the Carmel forest fire was unique that you had a highly densely populated area right next door to the forest fire. When you add all these up, a lot of people have said that wood smoke and forest fires are not as toxic as city fires. But when we look at the chemical properties, the magnitude of exposure, and in the case of the Carmel forest fire, we see that there's significant pollution, there's significant health effects from forest fires. We'll talk briefly about epidemiology of forest fires. The question is this: here's the pollution, and here are the people. How do you study the connection between the two? In environmental epidemiology, we always start with the exposure. What pollution is out there? With forest fires, there's 3 ways to look at it. You can look at area monitors, where you have mobile stations. In the Haifa Bay area, we have 15 of these stations that we have data from. You can look at satellite monitoring. There's a satellite through NASA that takes density of the smoke, and you can estimate what's the exposure from the smoke from the satellite. And then you can do a crude level of exposure assessment, which is basically say, here's a period before the fire, here's a period during the fire, and here's a period after the fire. And then without knowing exactly how much pollution or smoke there was, you can do a comparison between those periods. The second thing we look at is what are the health outcomes. Now that we've established an exposure, we can now look at either mortality rates, we can look at changes in lung function, we can look at the rates of emergency room visits or clinic visits. Those are some classic ways that we can assess outcomes. The final question is, how do we combine the two, the exposures and the outcomes? Almost all of the literature is cross-sectional, which basically says how much exposure do we have right now and how much outcomes do we have right now and what's the association between the two. A type of a cross-sectional study is a natural experiment where you say how much disease is there before the fire, how much disease is there during the fire. Basically, what was somebody's lung function during the fire and what was it compared to before the fire. That's a natural experiment. And then a more eloquent way to do it is do a time series analysis where you look at daily changes in the amount of pollution and compare it to daily changes in mortality and emergency room visits and the like. I did a brief review of the literature. I searched PubMed for 20 years of literature looking for forest fire, wildfire, and vegetation fire. I restricted it to large epidemiological studies and came across 26 studies ranging from throughout the continent: Brazil, Malaysia, California, India, even one study from Iran. To date, there's no study from Israel, but maybe we can change that. Just to look at some of the larger, I think, more definitive studies, here was a study from the Amazon that looked at the health effects of particulate matter during burnings in the Amazon. So basically, they burn huge areas of the forest to make room for cows and other livestock, and there are communities living next to it. They measured particulate matter, and then they looked at changes in respiratory rates of disease. They did time series analysis and found 10% increase in adult hospitalization rates and 8% increase in pediatric hospitalization rates per increase of unit of exposure. Another study from the Amazon looked at rates of inhalational therapy. They did a more crude study design. They looked at a period before, during, and after the fires, and they looked at acute respiratory distress emergency room visits, and they found during the time of the fires they had a 20% increase in visits. I would say probably the best study I came across was looking at Denver wildfires. They had big wildfires outside of Denver, and it was similar to the חיפה and the Carmel forest fires, and they had a large city with densely populated area right next to a forest fire. They measured particulate matter concentrations during the wildfires and looked at the amount of people who died during each of those days during the forest fires, and they didn't find a statistically significant increase. So this is probably the most comprehensive study I found, and they did not find an association between the number of people dying and during a forest fire in that period. There's multiple studies from California. This is an example of one that used satellite imaging to assess exposure. They looked at the rates of hospital admissions, and they found that there was a 34% increase in asthma admissions during the period of the fire, which lasted about 10 days, and also an increase in bronchitis, COPD, and other lung diseases such as pneumonia. One final study from California looked at an assessment of emergency room visits. They did a more crude study looking at pre and post forest fires. They found 40% increase in asthma emergency room visits and 30% in COPD, chronic obstructive pulmonary disease. The one study I found from Iran, just to know what our colleagues over there are doing, is that they looked at burnings of farms near a fairly large village in Iran. They looked at the pre-fire and during fire periods. The interesting thing about this study is that they not only looked at the respiratory symptoms, which is not the best way to ask the question because everyone defines their symptoms as differently, but they looked at lung function, which is a very objective measurement of outcome, and they looked at the medication usage, and they found that the people in this village had decreased lung functions and increased symptoms during the forest fires. That's just a review about 6 of the 26 studies that I came across. I'm working on a meta-analysis of forest fires and communal health effects, which hopefully Professor Green can help me with some of the statistics with there. But hopefully we'll be able to publish that and really look at, over the literature, what are the communal health effects, and then what can we learn at the Carmel forest fire. So this is really the question at date. This was a satellite image from NASA during the Carmel forest fire. This is where we live. This is the populated region, and due to factors that none of us could have controlled, it pretty much pushed everything out towards Cyprus and Turkey, which was very good for public health in חיפה and the area. It remains to be seen what effects, if any, there were in Turkey and Cyprus. But the thing to keep in mind is these particulates, although they are heavy, it takes time for them to come down. So if you have a fire, the heat's going to be pushing the particulates up, and they don't land until after they travel for some distance. And if you recall, the winds were very strong, so it doesn't seem like the particulates from the fire landed inside of Israel. This is an example of 3 of the 15 stations in the area. We have particulate monitoring for about 6 or 7 of these stations. These are just some that are near here. There's a station near Rambam. This is a station in Nesher, and here's one in Neve Sha'anan. And this is when the fire was, December 2nd, 3rd, 4th, 5th. And we see that not only do they not cross over WHO standards for 24-hour peak particulate emissions, they actually don't deviate from the normal, and they're actually a little less than what they were the days before the fire. One reason for this is that one of the instigating causes of the fire was the strong winds. The strong winds, which helped to start the fire, also helped to push the particulates outside of the חיפה area. That's not to say that there wasn't exposure in places like Tirat Carmel, places like the communities south of here, where the forest, where the smoke got blown over. But the key thing to keep in mind is that the fire happened pretty close to the coast, and it takes time for the particulates and everything to fall down. One thing that would drop more rapidly are things such as gases. Unfortunately, we don't have measurements of gases, we just have the particulates. Because of this, I think it's safe to say that there was not high levels of exposure to particulate matter in the חיפה Bay Area. when we look at the actual rates of hospital admissions, I've looked at total emergency room visits for one of the major hospitals in the area, and it actually went down 30%. There's some very good reasons for this. A lot of people left the area. About 15,000 people were evacuated. So the total denominator, the base population of the people in Haifa decreased. And also people were advised not to leave their houses. So I think looking at the number of emergency room visits in Haifa would be misleading. In fact, it looks like there were less emergency room visits in Haifa during this period. So to wrap things up, I think that there was minimal exposure, as we see from the monitoring data. There was a decrease in hospital emergency room visits, as we see from the Beit data. And I think to that extent, for our area, we really lucked out on the communal level health effects of the fire. But we shouldn't discount the difference between communal level health effects and occupational health effects. I think just looking at this picture, we can all remember that from Haifa, it was actually quite a beautiful picture of the fire. You know, you could see the glow and you could see the smoke going straight to the ocean. But it was a very different thing when you were on the ground. And I think the concern that I have and my colleagues have is what are the health effects to the kabayim and the sheltrim. So that's it. Thank you for your time.